Hello. Today we're going back to a topic I mentioned some time ago, and that's telemetry. The purpose of the telemetry would be that you might be running an expert advisor on a virtual private server, but you don't want to log into the virtual private server repeatedly just to see that the expert advisor is running, make sure that everything is fine, and maybe even get information from that. So by using telemetry, we're going to capture information from the remote computer and transfer it to your local desktop where you can monitor it inside MQL4 running on the local desktop. To manage telemetry, we're going to need a telemetry class. That's going to be a dictionary type class. If you search the internet, you'll find dictionaries available for MQL4. They're quite complex. I want to use something simpler today, and as this is a tutorial, I'm going to build our own as we go. So the dictionary itself will then need to store some key value pairs. A key value pair just being something that has a key and a value of different data types. Then once we have the telemetry class in place, that will need to store information somewhere, and then we will need a mechanism to move that information from the server computer to the client computer. I don't have a download of this information. This really is a follow along type tutorial. So I recommend that you watch it through, and then if you're going to try to implement this yourself, play it back and use the pause button to copy what's being done here. Now that I've covered the introduction, let's get into creating the KeyValuePair class first. This is the KeyValuePair class. I've already created the outline for it, so I've just got comments and the class description here. So let's start with the constructor. So in my constructor, I'm using function templating. I've talked about this in a previous video. I'll leave a link to that. I obviously want to store a key and a value because this is a key value pair and I don't know the type of the value, or I want to store multiple types of values. So I'm using templating here to allow different value types to be passed in with this type name of T. Then all I'm doing with those two, I'm storing the key that's passed in a key member variable, and then I'm using a set function to set the value that's passed in. First, let's create the member variable for key. That's just a string. And now here's the definition for the set function. And again, this value type is unknown, so I'm using templating here for the set function, and I'm just passing the value in, and let's create the body of the set function. So for the body, I need to again repeat the template statement. Set type T value. I'm capturing the type name because I want to be able to use that later in functions to extract this data from the key value pair. So I'm just getting the type name of the value that's passed in, and then I'm calling this other function called set value. So let's create those. First, the type name, it's just a string, so I'm just creating a member variable for type name. And now the set value function. And you can see here how it's a clumsy class, but easily extendable. I've created a string value, or a variable of type string that I've called string value. And then I've created a set value function that accepts an argument of type string, and all I do then is assign value to that string value. So this function here in the set function, when it calls set value, through function overloading, it will find the set value function that accepts the correct data type of value. Let's just create some more of these. So those are the four basic types that I'm going to create today: string, integer, double, and time, or date time. So next, I want to be able to retrieve values. I'm going to want to get the key back with the getKey function, and the type with the getType. They're very simple, just returning the variable names key and type name. Then I'm going to want to get values from the key value pair. So here I've created this, again, templated function. I'm returning a value of type T through the get function. Let me just straighten out the set function so the alignment's better. All right, now let's create the body of that get function. Now here you can see some of the clumsiness again. The get function has a return type of type T, but I can't actually use that to get the specific types of data. Or I could, but I want to return the type that was stored. So I've already captured the type name when the data was stored, and I'm just going through a simple set of if statements. If it's a string, integer, double, or date time, then I'm returning the appropriate values for those. And just as a fallback option here, if none of them match, I'm just returning an empty string. Let me go up here. The other thing I want to do as part of a key value pair, because I need to be able to serialize this data, I want to create a toString function that will return any data stored here as a string. So let's just, I'm going to create a simple toString function and then put the body down here. So again, the same clumsiness. If the type name is a string, then I'm going to return an overloaded function, also called toString, but passing in the string value. So I've simply created, or I will be creating, overload functions called toString, and let's create those now. So here I have the string value toString, and all I'm doing is returning the value because there's nothing to do with a string to convert it to a string. For the integer, I'm going to use the integer to string function, and then same for the double, using the double to string, and for the time, I'm using time to string. And if you want to extend this to other data types, you just need to duplicate these 3 lines for each data type and whatever the appropriate method of converting that data to a string. And then of course you'll need to go to these functions here and add another line. So if you wanted to do something like a long, you would just duplicate one of these lines and do if type name is equal to long. So quickly to go over this again, I have string variables to store the key and the type name. For each of the data types that I'm going to store in this class, I have a value of that type. I have a set value function accepting a value of that type, and then I have a toString function returning that. The constructor is typed or templated, so I have a key value pair taking a string key and an unknown typed value, and then I'm just assigning the key to the key variable and using the set function to set value. And the reason I'm using the set function is that it also captures the type name, and the destructor has nothing to do here. Then I have a get function, which is again templated to type T, and I'll show you when we do the telemetry class some minor complication with using this get function. Then I have the set function, which again using type T value, and finally the toString function. And then of course get key and get type just return the variables. Then for the get, I have this clumsy looking series of statements, and the same thing for the toString. Let's just see if that compiles. It doesn't. Looks like I made a mistake somewhere. Where is it? Ah, yes. I've put a colon at the end of this line instead of a semicolon, and that should compile. All right, and that's the KeyValuePair class ready to use. Now I have the telemetry class on screen. Again, I've created the initial comments. I've included the common functions for Orchard that we had last time. I've included the common base class because I want to inherit from common base, and I've included the KVPair file that we just created. So here's my class declaration: C telemetry inherits public from C common base, and then I've just created some placeholders. So the first thing I need to do is have a place to store the key value pairs. So that's just an array of type C key value pair, pointers, and a simple row array. Now there is no constructor for this. I don't need to pass any particular information when I first create it, but I do need to delete these rows because they are objects and I need to clean up the memory. So there is a destructor for this, and I'm just calling a function delete rows. And let's just Look at that. So the declaration for delete rows is here, nothing in there. Let's go and look at the definition of that. Put it at the bottom here. There's delete rows. All I'm doing here, I'm getting the array size of the rows array, beginning with the last element, array size -1, looping backwards using I minus minus as long as I is greater than or equal to 0, and I'm just doing delete the object in that element of the array. And finally, when I've deleted all of those, I'm just resizing the array to 0. So basically reinitializing the array. So next, we obviously need a method to set values in the telemetry. So I'm using templating here, type name T, passing in the key for the value that I want to set, and then the value of type name T. Let's create the function for that, and here's the templating again, set string key and type T value, setting the index to a find key function, which I'll create in just a moment. And as long as that key has been found, so if index is greater than or equal to 0, then all I'm doing is calling the set function of the KVPair to set that value. If it's not found, then I'm setting the index to the array size, resizing the array by 1, and I know this isn't as efficient as it could be, but I don't expect these to be very large arrays, and I don't expect them to grow very often. And once I've resized that array, then I'm simply setting the last element of the array to be a new key value pair, passing the key and the value. Now let's look at that find key function. So it's a simple returns an integer, which is where the key was found, passing in the string key. And let's create that now. Here's the function for it, simple find key string, and I'm just doing a very simple linear search through the array until I find a key that matches. This is, I expect this to be a very small array. I don't think it will take very long to do this kind of linear search. If I were using a very large array, I would probably find a faster method of searching, but this should do for now. Next, because I have a set function, I want to create a get function. Here again, templating for type T, getting based on the key, and I'm passing in a default value in case the key isn't found. Let's look at the function for that. So I'm using the find key function again to find the index of that key. If it's found, then I'm simply using the get function from the key value pair. And I mentioned that there was a little complexity to the get. There's no argument in this get function, so there's no hint for the compiler to know what type this T is. So I have to overcome that by putting the T inside angle brackets here. This function, this get function, has a compiler hint because I'm actually passing in a value of type T. But this function in the key value pair has no arguments, and I'm just reusing that type T inside the angle brackets here. And in case index is not greater than or equal to 0, then it will just fall through to this statement and return the default value. Then, because I'm going to be doing serialization on this, and in this case I'm not going to bother to return a lengthy string containing all the values, I'm just going to use save and load functions to save this to disk and recall it. So let's create those. Very simple. I'm just going to pass in a file name string to the save and the load functions, and they're both going to return booleans to indicate whether they were successful or not. Let's create the save function first. So save function, passing the string file name. I am going to force that there is a key value pair called time current that holds the current time, and that is so that I can always look at the output from this file and know the last time that it was saved. It can be used as a heartbeat function for the expert advisor, because then you know that there will always be a time current value in the output, and it will always show the last time this ran. Then this is a simple file function doing a file open of type CSV read and write, setting the delimiter to a comma, and retrieving the handle as long as that was successful. So as long as the handle is not the invalid handle value, then I'm just counting the size of the M rows array and looping through from 0, counting up. I'm writing using that handle, and the file write function for CSV files takes multiple arguments, each one separated by a comma, and it will just write these into the columns of the CSV file in this order. So I'm writing the key first, the type name for the variable, and then the string representation of that variable from the KeyValuePair function, from the KeyValuePair class. And finally, I'm flushing that information to disk and closing the file and returning true. Of course, if the handle did not open correctly, then I'm just going to return false from this save function. So now the load function, again taking a string file name, standard file open, this time it's type CSV, I'm just opening for file read, I'm specifying the comma separator again. I'm setting up 3 values, the key, type and value, as strings to read back from this file. Same test, if handle is not equal to an invalid handle, then first thing I will do is delete the rows that I have in the telemetry class already, because I'm not trying to add this to any existing data that I have. I want to restart. So as long as I've been able to open the file, I'll delete the rows. Simple while loop until I reach the end of the file. I'm reading in the key, the type and the value using the file read string. So for a comma separated file, I don't need to specify any length of the string that's going to be read. This will just read up to the next delimiter each time. And as long as this is the file that was created by the save, I know there are going to be 3 columns, so this is fine. In a more robust class, you might include some error handling for this, but I know that I'm only reading and writing from this one class, so this file should only have these 3 columns. And then more of the same clumsiness, because I need to understand the data types. So if you do extend this to create more data types, you'll need to also add lines here. But this is basically because the value has come back as a string from the comma separated file, and then I simply want to set that value into the appropriate data type. So if it's a string value, I just call set with a string value. If it's an integer, then I'm using string to integer or string to double and string to time. And because the telemetry class is storing an array, I'm also going to add in some functions to retrieve the key and the data type by position number. So first a count function, so I know how many elements are in the array, just returning the array size, and then a get key and a get type, each taking the index or position, and I'm just using the get key and get type functions from the KVPair to return the value for that row. So now I'll create some test scripts to show how this works. This is my test save script. I've already filled it in, there's not much to see here. I'm simply doing an include of the telemetry file. I'm creating an object of type CTelemetry called test, and then I'm just setting some values. First I'm setting something with a string key and setting it to a string value. Then I'm creating an integer, passing an integer value, a double, and then I'm demonstrating here with these 2 lines that although I might want this first to be a double, the value I'm passing in could be stored as a double, but it's actually being passed as an integer. And this is the correct way to pass a double value constant into this function. And then I'm just storing a date. And then I'm just going to use the save function to save these in a folder called telemetry. Now, this is a Windows system, and the path delimiter on Windows is a backslash, but a backslash is also an escape character inside a string for MetaTrader, so I'm using 2 backslashes. So this will save a file called test.csv inside a folder called telemetry. And then the load script just does the opposite. I'm still including the telemetry file. I'm creating an object of type CTelemetry. I'm loading from that same file, and then I'm looping through all of the elements in that array. So simple, retrieving the count, looping from 0 up to the last element, I'm getting the key and the type with those two getKey and getType functions. They're both strings. But then, because I again need to deal with different types of data coming back in the different elements, I have conditional statements here. If the type's a string, then I'm going to print the key, the type, and a string value. If it's an integer, then I'm going to print the key, the type, and an integer value, and I'm getting that by passing in an integer value as the default. Double, I'm passing in a double value as the default, and for the date, I'm passing in the date a date value as the default. So now let's run the test save function first and see what that does. So no errors when I ran that. If I just switch across to the folder, I go into MQL4 and the MQL4 files. Here's the telemetry folder that's been created, and there's the test CSV file. Just edit that with Notepad, and you can see here the keys: string key, integer key. Let me increase the font size so this is easier to see. Integer key, double key. Should have been a double, but you can see here the data type is int, as expected, where this, the same value, but because it was passed in with the decimal point, it's been stored as a double type. And then the date time and time current, remember, is the default value that I add before saving. So this was actually saved there. Now let's go back to the test load function, and just before I run this, let me make a note. Because I'm retrieving a date time and the print format doesn't have a format specifier for date time, I'm actually going to do a time to string conversion on that. Right, now I can run that. Go to the terminal window, and here's everything: string key, integer key, double. There's the double that was stored incorrectly, it's coming back as a type int, and the same double that was stored correctly coming back as a type double. These are type date time, but I've already formatted them to a string. So that's the storage and retrieval using the telemetry class. What we need to do now is be able to move that information onto a different computer so that you can actually use it as telemetry. Just before I do that, let me mention, if you're using this save, I've done it in a script here, so it's a single run. If you're doing this inside an Expert Advisor, I recommend setting up a timer inside the Expert Advisor, not saving this too frequently. Maybe once a minute should be enough. If you save it too frequently, you'll be using too many system resources just saving a file when it's really of no value in a remote monitoring. So now let's see how I'm going to get that file across to the other computer. I have two virtual computers running here, so things will be a little bit slow. This is my original demonstration computer. That's going to be the server for MetaTrader, and this is the client computer that I've set up to show that we can retrieve the information from the server. And to do that, I'm just going to use Dropbox. So let's have a look at the Dropbox folder first. Here's Dropbox. I have nothing else in here. And let's open Dropbox now on the client computer. And you can see here, this is the demo client, and on this computer, this is the demo, which is my server. So I'm going to create a folder here, which is my telemetry folder for sharing information. Now I'm using Dropbox. You can use any cloud sharing application that you like. Let's create the new folder first. Right, so there it is on both computers. Now I need to move the file from MetaTrader through that shared folder. I'm going to start up MetaTrader. As I said, this is a little bit slow, so I might just skip part of the video here while I load MetaTrader on the two computers. Now I have MetaTrader loaded on both computers, and I've used File Open Data Folder to get to the data folder. So here in the MQL folder on my server computer, I go to the Files folder, and this is currently empty. Here, and the Files folder, and this is currently empty. MetaTrader by default will only write data, or read data in fact, into the Files folder inside MQL4. So I don't have access directly to the Dropbox folders that I've set up. I could use DLLs inside my applications, but I'm trying to do this without using a DLL, so I'm going to use a little bit of trickery instead. So just if I create, or let me go back to MetaTrader here, and if I run the test save script, run that, and then go back to the folder, you see it's created the telemetry folder with the test CSV file in here, but nothing appears over here. So what I want to do is have this file created inside Dropbox. Let's go back to Files, and I'll delete that for now. So I'm going to use folder linking. So on Windows, open the command prompt, and you want to right click this and select Run as Administrator. You'll need the administrator privileges to do this. Or on Mac or Linux, you'll be opening the terminal. Now I'm going to navigate into this folder, and rather than retype this string, I'm just going to click here, Control C to copy that, go to the terminal, CD and Control V to paste. That puts me into that folder. To move this data into Dropbox, I'm going to use the mklink command on Windows. If you're on a Mac or Linux, you'll use ln-s, and I'll leave you to investigate the syntax for this. But for Windows, the syntax is mklink/d, because I'm creating a directory link, the name of the folder that I'm creating in this folder, Telemetry, and then the path that I'm going to link this to. And because I'm on Windows, I'm going to use the environment variables to find Dropbox. And that Dropbox/telemetry is the folder that we created earlier. There's symbolic link created. If I go here and look at my MQL files, you can see telemetry, and it has this little glyph showing in the corner of the icon. I'm going to do the same on the client computer. I'm just going to pause the video while I do that and then come back. Now on both computers, the demo, which is my server, I have the telemetry folder, and on the demo client I also have the telemetry folder, and both of those point into the Dropbox folder. In fact, if I just go there to Dropbox. Now if I go back to MetaTrader and I run this test save client again, put that away, you can see this test.csv file has been created inside Dropbox, which is the same file as the MQL folder. And if I now go to the client computer, there is the test.csv. Obviously it takes Dropbox a little bit of time to do this transfer, which is why I also recommend that you don't try to run this too frequently inside the Expert Advisor. But now on the client I can run, let me get to Experts folder, I can now run the test load, and you can see it's reading the data back from that file. Conclusion. That is everything for this demonstration. Obviously, the information that you pass in this telemetry file is up to you. That's everything for this demonstration. Obviously, the information that you pass in this test, that's everything for this tutorial. Obviously, everything that you're going to pass, the information in this telemetry file, is up to you. I also recommend, if you're doing this from an expert advisor, that you include in the file name the name of the expert advisor, the magic number, and the symbol. That will avoid conflict with other expert advisors you may have running on different charts. But then with this, you can use it simply to monitor the health of your remote server and to check on the activity of the expert advisor without the need to remote desktop onto the virtual private server. I hope this has been useful to you. If it has, please click the like button, and if you'd like to see more of these videos, remember to subscribe and click the bell icon to be notified when we release more videos. For now, thank you for watching. Bye.